Hello everyone. So in this session, we'll be using RAG implementation with META LLAMA 3 8 billion parameters. Now, if you remember in the previous two sessions that I've done, I have introduced, question answer model. We have seen that given the documents, the context, and the question, the model will give a crisp response to the point answer. And in the next session, we have seen summarization model when you have given the same model, given the same document, the context, the response is summarization. And in this model, which is META LLAMA 3 8 billion parameters, when you give the same context question, it will give you much richer response. The contextually is going to be much richer. Okay, so now for this 8 billion parameters, we're going to require GPU. So I'm not using a pro version of Google Colab, the free version only, and we'll see one certain change that you need to do, and post which you can use Google Colab itself. So yeah, let's go into it. I've already have the flowchart in front of you. So when each and every steps that I do, I'm going to take you through this flowchart and then do the coding as well. Also, one thing, I'm not going to put all the packages at once, install it at once. I'll do it as and when required, because in this way the purpose will be served. Which packages will require when, you will get to understand it properly. So yeah, let's start off. This is where you go change runtime, and then you'll put it T4. Okay, T4 GPU. So now what I'll do is, as you can see in the flowchart, okay, the first part is the PDF part that you uploaded, okay, because we will push this document, and basis of this document only we will use the LLM META LLAMA, given the question and the context, how well it responses. Yeah. Okay, now let me quickly upload the PDF here. So we have already, since people who have already followed me, they know the PDF that I have, which is of paracetamol, and yeah. So and it consists of 6 pages. Okay, not a big file. Okay, while it is taking time to create this folder, what I'll do is I'll straightaway go and install the first package. The package that you're going to require is Langchain. Okay, Langchain. I'm going to use in every step, starting from okay, the folder is getting created, so I'll name the folder as data, and I'll quickly upload it. Now here you're going to see the PDF will get uploaded. The PDF, as I said, is a paracetamol related PDF. The document has all the information related to paracetamol. So the first package that I was trying to install is Langchain community. So pip install. So while the installation happens, it's going to, there are a lot of things. Requirement is already satisfied because I've already done it before. I'm going to hide this out so that we understand every time. So first thing is that we'll upload PDF, so we'll require this package. Okay, so pip install PyPDF. Now why PyPDF? Despite we're using a Langchain, because all these dedicated softwares are going to do this heavy lifting. Langchain is just going to be the wrapper. Okay, so from Langchain, I'm going to have document. So document loader is the class. Okay, so what we're going to import from the document loader, PyPDF loader. Okay, load here. Okay, that's the package that I'm going to. Okay, a different package got loader. Okay, so I'm going to use this. Let me name it as raw doc initially. Okay, and then I'll have to just put the path here. So the path, you're just going to copy the path from here and then paste it. That's it. Now if you try to look into the raw doc now, the document won't be available as of yet, because this is just instantiating it. Okay, so if you see here, when I say raw doc, it just says that yeah, it has instantiated now. Now in order to read it, I'm just going to copy this and mention it as sorry, delete this one. Let me quickly, raw doc is what I need. Dot load. Okay, dot load is the command, and let me put it somewhere. Okay, I'll name it as not the doc. Say this is just going to be your raw load. Okay, raw load. So we'll see raw doc here. Raw load. Let me put a different name. So if you will see all in the entire PDF has come. Okay, the information that you will be interested in, page content, but let me show you how many pages that I say. It starts with 0 and it will go till 5. Okay, we are in page 3, somewhere should be page 4, and we'll have page 5 as well. So there are page 5s. Okay, 5 pages, pretty small. Okay, and if you remember, let me go to the diagram now. Once we have uploaded the PDF, the very next thing is embeddings. Okay, so before embeddings, you have to have this uploaded PDF into a splitted form. Okay, into a chunk form. Okay, now we'll have to do this chunk before we proceed into embeddings. Now, how do we go about doing that? Again, we'll from Langchain dot text splitter. Okay, text underscore splitter. This is the class. Import. I'm going to import recursive character splitter. Okay. Now this recursive. Now in this recursive character splitter, we're going to give the two parameters. Okay, very important parameter, because here only you are going to declare the chunk size and the overlap. Okay. Now I said the chunk. Okay, we'll have to make a chunk, but chunk size of what? You'll have to call this out. So since my PDF is not that big, I'm just going to make it 100. Okay, chunk underscore size. And chunk overlap is nothing but when you are creating those chunks of data, right? So what happens is when 100 is the length, in sequence to sequence, you want to keep some information of the previous so that the model does not forget the relevance of the next step with respect to the present step. So we're going to create that overlap. So chunk overlap. So I want a chunk overlap of how much? 20%. So I'm going to put 20 here because I've taken 100. Okay. And now let me put it somewhere. Let me call it as this is as a splitted. Okay, splitted text, and we'll see that splitted text how it looks. Chunk size. Did I put in a capital S? Yeah, it's going to be all small. Okay. As of now, I'm sorry. As of now, it just got instantiated, but in the next step, we're going to split it. Okay. So split documents. Okay, split documents, and what is the document we have is a splitted text, right? Sorry, not a raw load. Raw load has the data. Okay, and I'm going to put it as name as text split. Yes, split, and we will see this text split as well in the next step. Now this is where you see everything got chunked and splitted in list. Okay, so if you see, it starts with a list. So I have page. Now look at the page 0000. Then we'll have starting with 1. So you must have understood now. All it's put into in one list, Python list, and you have then chunks. Now once my chunks is done, which has chunk size of 100 and overlap of 20, the next thing is that embedding. Now embedding process will require the model and a database where you're going to put the embeddings. Okay, so yeah, let me bring the model. Meantime, I'll just this is the embedding model that I'm going to use. Okay, now in order to use this model, I will need to have sentence transformer installed. Okay, because we're transforming a sentence, right, from text to a vector form. Now so that's why you will going to require a sentence transformer. So pip install sentence transformer, and another package that is HuggingFace embedding. Okay, since we'll be use HuggingFace embedding, so so now what I'm going to write here is from Langchain dot embeddings we're going to import HuggingFace embedding. Okay, so these two things, you are going to install transformer, and you're going to from Langchain embeddings, HuggingFace embedding, you're going to run this. Okay, so requirement already satisfied. I'm going to just hide it out. Now I'm going to show you the model. So embedding model sentence transformer, I have mentioned the model name, and so for embeddings, HuggingFace embedding model name, this is what I've shown you. Now I've told you that you must be saying that he's using sentence transformer as well as HuggingFace embedding. Why? Both of them. All the heavy liftings will be done by sentence transformer itself. Okay, HuggingFace is just going to be an operator. So wrapper. So it's just going to be there. You'll have to bring this package down. Okay, so once these two steps are done, my embeddings sentence transformer is sentence transformer is not defined. Did I not call a sentence transformer? Okay, so from what you have to go do is just go above here and just say from sentence transformer. So this is the sentence transformer. I'm going to import this. Now let me run it. So now your embeddings are all ready. Okay, and now you'll have to push it into a database. Now let me go back to that chart that I've shown you. Once the HuggingFace embedding is done, okay, the next thing that you're going to put this raw text that we have in embedding from into a database. So now you have the embeddings ready. All that you will require is convert that raw text that we have into embeddings format, that is into a vector format, and put it into this specialized software, specialized database. Okay, you cannot use any database like MySQL and all. This is FAISS database, which is from Facebook, and it is specifically designed to store those vector embeddings. Okay. Now this I've explained very well in my previous video. So once you have embedding model, so these are the packages that is going to get installed. Okay. So now, since you are going to put it into FAISS database, you need to pip install FAISS CPU, FAISS FAISS dash CPU. Okay, and now from Langchain, pip install FAISS CPU, and from Langchain dot vector stores. Okay. So you've seen, like, dedicated packages are getting installed at the same time from Langchain also. So from Langchain for this vector embedding, where you're going to put this embeddings, you need to call this vector stores. Okay, vector stores import FAISS. Okay, FAISS FAISS. Now in the next step, what I'm going to do is I'm going to mention it as FAISS equals to FAISS dot form documents documents. Now what which are the ones that you're going to put it? You remember the splitted text split? This is the final text split that we have. Now we want to convert these into embeddings. Okay, so and the embedding model that you have to give, which you have defined it just here, HuggingFace embedding, right? So I'm going to mention this. So instead of naming it as FAISS DB, let me just put it as DB. Okay, and then we will check what is there in DB. So while all this is done, we'll be able to see if it got instantiated properly or not. Okay. Yeah, so if you see Langchain vector store, it is done. Okay, install package. Now all the embedding part is also done. So I'm going to pause it here. Okay, now we've put the embeddings in the FAISS database. Now, before we go into the next step, let's understand why we have chosen a FAISS database. There are other databases too, which is ChromaDB, which can do similar kind of works, but we cannot do with our traditional databases like Oracle DB or MySQL DB. You cannot do that. Now, let's understand some important features of this kind of a databases. Okay. Now, FAISS database, we talk about efficiency. So, FAISS is optimized for a nearest neighbor search. Now, this becomes very crucial when you do a nearest neighbor similar vectors. Okay, in a large data set. Basic data structure lacks this kind of a optimization. The second is scalability. So as your data size grows, the performance of the basic data structures degrades significantly. And your FAISS database or ChromaDB, it's meant to handle large data set like this. There are some advanced features too, like it can provide the feature of clustering, and then quantization, which you will see up next, and then GPU sort of a features, yeah, and then memory management. You understand now why memory management would be very crucial in FAISS database. Okay. Now, in terms of integration, it can quickly integrate with Langchain. Your basic data structures will lack there. That's the reason why this sort of a database we use. Now let's quickly go. Let me hide this out. Yeah, and let's quickly go up and see the chart. Okay, flow chart. Now you see, I mean, we have the database being pushed. Now let we be the user here, and now we'll have to establish a connection. Okay. Once we establish a connection, then we will have a question and context. Okay. So let's establish a connection first. Since we have already created the DB, I'll say retriever. Okay, retriever as a name of the connection. And then we'll put DB is the name that we have given already. Sorry, DB dot as as underscore retriever. Okay, And now this has, we have established a connection. Now let's see whether it got instantiated or not. See, vector store retriever, HuggingFace, vector store Langchain. So it has established. Okay. Now, since it has already established, now I'll show, how you will play. Now next, whatever you have to pull, you have to use this object in order to pull the whatever data you want to pull. So next up, you have seen that we'll create question and context to LLM model, but LLM model is not built yet. So what I'll do is, this question and context is a very simple step that will do it later. As of now, let me just create the LLM model first. Okay. Now, yeah. So for LLM model, there is you will require few package. Let me first pull those packages, and then we'll go about. So we'll require we'll do pip install torch, and I've mentioned the specific version. I'll tell you why I've done so. We need torch vision, we need torch audio, auto AWQ, and I will put this auto AWQ kernels. The reason why you see these versions that I've missed, I've already spent around 2-3 weeks to understand this. Okay, it fails every now and then because the auto W key dependency on this. Torch is required because all the tensors that tensor way it will work, you will definitely require torch for it. So auto WQ depends on, it has some dependency on torch version and torch audio. That's the reason I have mentioned this. Now, and I've also made auto AWQ kernels. Now, why auto WQ? Okay, we'll see. We'll be using a quant model. Okay, I'll be describing more about it when it comes. So let's do this package. Installation of these packages first, libraries first. Now you see when this installation will happen, chances are that it's going to fail here. Okay, so do not worry if it asks you to restart it. What you quickly can do, you can restart the session and run all the code instantly. Okay, you can go to the runtime here, run all the codes instantly. So yeah, let's have this installation done first, then we'll go about package. Now it's going to take some time for this installation to happen. Okay, there you are. I have paused this video because it took some time, and now it has asked me to restart the session. Okay, and this is happening because of the dependencies. So while you do the restart of the session, you click here. What you can do is go to the runtime, and you can run all. Okay, so let it run. It is going to take some time. Meantime, I'll again pause this video. So there you are. We have the installation of the entire process done, as you can see, when we have restarted and ran it again. Okay. Now, once this is done, so up next, what we have is torch. Now, we'll import the torch, but before we import the torch, let's install very important library that is called as your transformers. Okay. So while that's install install, yeah. While the package is getting downloaded, in the meantime, let me import torch now. Import torch. Now you saw this hassle that we had to restart the session. Why it's happening, I'm going to tell you next. But let's first of all import it. We'll import torch and from transformer, okay, which we have just installed transformer now. Transformer. There are a couple of packages. I'm going to install it one by one so that you understand. Okay. First of all, I will need auto tokenizer. Okay, auto tokenizer. I'm going to need your auto model causal LM, and I will also need auto config. Okay, auto config. These 3 libraries I'm going to require it. Okay. Now, auto tokenizer, you know it. It is going to tokenize it. This I'm going to use it for our pre-trained model, and auto config. Why I'm going to use it? Let me come to it next. So the model that I'm going to use it. Let me go to HuggingFace model now website. Now this is a HuggingFace model website. If you come here to the models and then click any model, for example, say if you type META LLAMA. Now if you see here, you need to agree to share your contact information to access this model. Now if I want to access this model, Llama Vision Instruct, I'll have to give I'll have to share some details in order to have this. So if I expand this, you will see it will ask for some certain details as you go down. So first name, last name, all this information you have to sign, and then you have to submit it. Post when you submit, you'll have to check it here. You will get a mail or So if you come here, if you go to your settings, you need to first of all sign up. Okay, sign up in HuggingFace. Only then you will have these settings and all. So if you go to settings, and then if you go to access token, So just like me, I've got a fine-grained access. You will also have an access token here. The access token will only come after you have filled the form and you've submitted it. Once they have given you a permission, then you can create a token here. So once you create a token, how do you create a token? You give it any name called, call it META LLAMA, whatever you want, and then you ask read, write, access. Probably you can click into all the ones, and then you just create a token. So once you create a token, you will have a access token here. So you can copy that code of access, and then use it in the code, okay, which I'm going to show it to you next. So in our case, the Llama model that I've used, which is a quant model. The reason why I've used a quant model is because if you use this 80 billion META LLAMA 3 80 billion parameter as is, probably the model is going to crash as you run it. Reason being, it requires a high resources. So the one that I'm using, the quant model itself is going to take 6 GPU. If your a computer or laptop supports that kind of a resource, if you have that kind of a resources, do definitely give a try. But in Google Colab, you can run the quant version for sure. So what I'll type here is I'll type the quants. Okay. Yeah. So this is 70 billion. The model that I've used is 8 billion. Let me just check if I can get that 8 billion instruct autoquad. So this is the model that I'm talking about. So I already have a permission on this. So how are you going to do it? So there are many ways of doing it. Either you download the model in your laptop locally and do it, okay, or you can use the endpoints, okay. So I'll just copy it from here and I can put it in my code, okay. Let me go to my code. Okay, if I come here, I can put it, and this is going to be my model, okay. So I have not executed after I've run this. Let me execute this. So this is the model that I have. Now that you know how to get the HuggingFace model using the model ID, I've put this, right? The next thing that you have to do is you will have to go and get from HuggingFace the access token, okay? So with the access token, see from HuggingFace_hub input login, and using the login function, you put the token here. How do you get the token? I'll just show it to you once again. You'll go to your profile, go to the settings, and then go to access token. So in the access token, see this is once you create, this is how it is. You cannot copy the value, okay? So what you have to do it, once you create this token, which I've already shown it to you, you put a name and you get an access of all this, okay. You can click check all this and then create a token. The moment you create a token, it is going to pop up a window and ask you to copy the token, okay, and make sure that you save that token, because once you lose it, then you are losing it forever. You have to recreate it again, okay. So you copy the token, you save it somewhere, and then you put the token here as well. Once you have put the token, I just import OS and I have to read this token from the cache of HuggingFace token, okay. Once I've done this, I have authenticated myself. I can easily go and use this model, okay. Model ID Hugging Quants, as you see, and this is the reason why when you use this quant, okay, you need this auto config, okay. The next thing that you see, you must have seen this now. This is the thing that you'll have to type it out, okay, on your own. Now let me go back to the HuggingFace website once again. Here also they're going to guide you. Use this model, okay. So if you see deployment, if you go inference, okay, leave it, use this model as a transformer if you try to use. So they give you, okay, how you can use it. But given that I'm doing a RAG model, those pre-processing part, they don't have it here. Just how to use this model, you can just try it from here. But yeah, you'll need to do a lot of processing. So let me come back to the place here. Now, this is why because of this quantization, I have just taken this part. But let me also explain you when I'm taking a quantization of INT4, that means it is a bit 4, okay, which I'm exclusively calling it out. Now let's understand what will happen if you have a bit 4. There are certain limitations, okay. Now this is from my another notepad, Jupyter notebook. The comment that you see here, 32-bit floating point numbers, okay. The one that you are using in a quant model is a 4-bit, and 32-bit floating point is what? Now after a dot, if you have 7 digits after that decimal, okay. Now if you remember, I've said 8 billion parameters, right? These 8 billions are nothing but these are weights, okay. While training the model, you have 8 billion weights. Now how is this? Each and every weights that you see are numerically defined. They are floating numbers, okay. Now when you have 32-bit floating precision, that means there will, after decimal there will be 7 digits, okay, 7 digits to maintain that precision. When it comes to 16-bit floating point, you see after decimal there will be just 3 to 4 digits. And when you have 8-bit floating point, 1 to 2 digits, and 4-bit floating point, only 1 digit. So you must be wondering, we are just doing 4-bit. I mean, we are definitely compromising on the precision part in order to have that faster, computation. But it's not that bad. it does not degrade significantly. But if you go to the HuggingFace model, as you look for a quant models, you will see some of the quant models, they call out at the bottom that if it reduces the performance significantly. Now, I've also given you one example for 4-bit floating point, which has just 1 digits. Now, you can imagine that when you have a value like 0.123456, okay, suppose it is one of the weight. So when you quantize it to 4 digits, it takes a nearest value of 0.16. So you must be you must be saying that at point number 4, you said for 4-bit floating point, just 1 digits after decimal, but I can see here 2 digits, right? So this is some mapping being done, okay, after 1, some mapping being done in order to get that value 6. That's why I mean, when you have a value after decimal 1, 2, it did not take precisely 1, 2. Okay, so it took 6 because some amount of mapping that happens for that last digit for 4-bit floating point. So I hope I was able to explain you this part. And 16-bit floating point, this is being used for training, GPT-4 large model. Okay, this reduces the memory usage and speeds up the computation compared to 32-bit precision while still maintaining acceptable accuracy. Now you must be wondering, we have 32 GB, why not 32 GB being used for Chat GPT-4? GPT-4. See, I mean, even 32-bit floating point is used too. Okay, but it is used in certain situation like operation during gradients. Okay, not in all the steps. The steps where for 16-bit floating point was required, they have used it. 32-bit floating point, they have used it. Yeah. So if this part is clear now, so now you would have some amount of idea now when I'm talking about 4 bits, what it is. Okay, so I've exclusively called it out. So I've given it a name called my configuration for quantization is I've given it a name quantization config, and then I'm putting this function here, whatever I have pulled this library from, and then I've said bits equals to 4. Fuse max sequence length is 512. So your sequence length for each sequence, it is going to be 512, even if, yeah, so it is going to maintain that sequence 512 every time. Even if it doesn't have, it will do the padding, but it will have that sequence. And do fuse equals to 2, because now since we are trying to be efficient here, since we don't have much resources, we're saying that multiple operation that you do, you fuse it into 1. So that's what it says, do fuse equals to true. So I hope this part is clear now. I'll bring the rest of the model code here now. So the next part is your tokenizer. If you see auto tokenizer, I have used this auto tokenizer dot from pre-trained model. Model is nothing but my HuggingFace model only. So what is tokenizer going to do here? It is going to tokenize it. Okay, all your before you whatever thing, I mean a text that you've passed, right? It has to tokenize that. So this is what it will do. So model that I'm using here is this model itself. Now the next thing that we have is your auto model quotient, which we'll be using for training it. Okay. So next part is this model. Okay, so I've just copied the code. That's why you didn't see it. You didn't see me typing. Now what I've done is, if you see auto, this is a library that I have pulled, and this is the library that I'm going to use for the model. Okay, so I'm going to put it auto model for causal LM from pretrained dot pretrained every time you have to use it. Okay, because you are using pretrained model only. So I put my model ID. Model ID is nothing but my this HuggingFace. I mean, whatever model that I picked from HuggingFace. My torch type will be torch float 16. Low CPU memory uses, I have put it true. Device map auto, and quantization, whatever I have declared here, I have put it here. Okay, quantization. So my tokenizer, and this is also ready. My model is ready. Now what I'm going to do is I'll have to make the pipeline so that I can connect all these two together. Okay, so let me pull in my. So you'll have to first of all from transformer, you're going to import the pipeline, which I could have done it here once I have installed the transformer. I could have done this pipeline, but I'm doing it now from transformer import pipeline. So now I'm going to use this pipeline. Okay, I've given it a name called text generation pipeline. Now in this the motive of this pipeline is to integrate tokenizer and model. Okay, if you see, I put the model as is, the model itself, tokenizer as the tokenizer, this tokenizer, and the task whatever we're doing is a text generation. Temperature, I've maintained it 0.2. I'm going with a greedy approach. There is an the reason I say the greedy approach is because the higher the number it is, you can put it between 0 to 1, I think. The higher the probability that you put, the better is the randomness and more creativity. But when you have the temperature as set to lower value like 0 to 0, 1, you are setting the model to very reserve. It is going to pick the most probable words. Okay, with respect to probability, what is the most probable words that you have? It's going to bring that. Okay, now do sampling equals to 2. That means I'm saying that you bring that randomness, and then repetition penalty that I'm putting. Okay, if it is a higher than 1, you're trying to give penalty if there is a repetitive use of a single word. Okay. So yeah, that's what it does. I'm saying when it's greater than 1, it is definitely going to take care of that. So return the full text true. I'm saying that max new tokens is going to be 400 only. So I'm building now. This is the entire pipeline that we have. Now, if you remember, I think I've not called HuggingFace package. Let me quickly pull HuggingFace pipeline. So I'm putting the package here. Okay. So I have this HuggingFace pipeline. So I'm putting this pipeline is this text generation, and that's my LLM model. Okay. Let me execute this. So I think it's going to fail because I have not executed this part. Yeah, from here. So model ID, this I need to run. It says auto config is not defined. Let me check if I have run this part. Pip install is done. Auto config I have executed. Okay, so it's not going to be your auto config. It's going to be awq config. Okay. This is done. I think you will have 2 shards. Okay, and this is where you can see your GPU will go really high. Okay. And you can see all of a sudden it went to 3.5 while loading the checkpoints. 5.7. Okay. I was assuming that it will go to 6.1, but let's see. Okay. Now let me run this part. It happened. Okay. So now you see 6.1. I think that's the highest it will go to. Okay. Now my model is being run. I have the model ready. The next step is, if you remember, if you go to the chart that I have drawn here, my LLM model is ready. Now we'll have the question and we'll have the context, and then we will try to have question answer RAG session here. So let's have the question here. So let's say I'm putting a question here. So if you remember, my document was based on paracetamol, right? So let me ask this question: what age group can have paracetamol? Okay, I'm putting this question. Now, whom I'm going to ask first of all this question? To the database. It's going to hit the database first, if you remember again. So first of all, it is going to ask this question to him to FAISS database. FAISS database will respond, and based on that, we're going to create a context. Once the context is there, we'll have the question and the context, and we'll pass it to LLM model. Okay. So I have passed this question, and I'll pass this question to your retriever. If you remember, I've created a retriever here to establish the connection between the database. Okay. I'll quickly copy this and I'll put it here. Okay. Retriever dot invoke. Invoke is the command, and I'm going to put the question. And let me put it as context. Okay, because this is where your context doc is. Okay, and then we'll see what our context doc will be. Okay. So you see, I mean, from that it has given you this. So from page 1, it has said that paracetamol is not recommended for children under 12 years of age, other formulation containing so on and so forth. I mean, it has brought all the relevant information only. If you see, if you are elderly, if you have alcohol problems, liver damage, okay. So those relevant information, it will look through the entire document that we have uploaded, and based on that, we have retrieved this. Okay. So far, we have not played any game with the model as yet. Now we have to make this context ready. So I mean, this is not the way that you can pass a context to the model. Okay. So we'll have to take only this page content. So let us create that. Okay. Let me name it as context, and then what I'll do is I'll apply, I'll do a comprehensive list for I in, I'm going to take this context doc. Okay. So what I want to retrieve from here is I'll put I dot page content. This is what I need. Okay. And what I'm going to do is I'm going to join this so that all of them will club up, and then I can have a context join join. Okay, so let me check how if my context is already. Yeah, so everything has been combined properly. Okay, all into one. Now this I can pass as a context to the model. So I have the question ready, I have the context. Okay, now I'm going to pass it to the model, both of this. Okay, but I'm going to use your Langchain template. Okay, so this is the package that you're going to require. from Langchain dot prompts import prompt template. Okay. Now with this I'm going to create a template now. So I've named it as prompt underscore template. You can give it any name that you like, and I've given 3 quotation in which I've said that use the following context. This is what I'm going to pass it to the model as is. Okay, the pipeline that I've created. So use the following context to answer the question at the end. If you don't know the answer, just say that you don't know. Don't try to make up your answer. Okay, that's what I'm saying here. And then I'm passing the context and the question. So context and question both will be in curly braces. Okay, these are 2 input parameters. So that's how my prompt template is defined, passing this to question. Okay, so let me run this part too. So as of now it is not done. You have just prepared the template. Now let's see the next step. So in the next step, this is the prompt template library that you've pulled in. I'm going to use this. Okay, prompt template. Now if you remember 2 input variables that we are passing here, because I'm going to use this prompt template now. So, and I'll have to also say to the model that there are 2 input variables only. Okay, the context and the question. And the template that I'm passing is prompt template. So everything I have put it in one line. Okay, prompt is prompt template. Now if I run this, okay. Now let me go to the next. So this is the sequential thing that I have done. First of all, I'm going to pass the prompt. This is the prompt that you're going to pass, context, question, and you are passing it to LLM model. Once the LLM model gives the response, it will come out with all model parameters, okay, the ranks, scores and all, but we are not interested on that. That's the reason I'm saying that string output parser, okay, only pull out the strings. Okay, now I don't have this package, so I'll just call it out from Langchain dot output parser, string output parser. Yeah, that's what you need now. So let me run it now. Okay, so it has run it. Okay, so far answer is not there. It was able to execute without any error. Now it's the time that we're going to invoke it. So if you remember the 2 things that we are passing, context and the question. Okay, and yeah, that's it. The questions, if you remember, it was what age group can have paracetamol, and the context also if created here. Both we are passing it, and let's see how the response would be. Okay, use the following context to answer, so don't make it on your own. So blah blah. Okay, so its response starts from here. Let's see. Paracetamol is not recommended for children under the age of under 12 years of age. Other formulation containing paracetamol is recommended for children 12 years in age. See, such a richness in answer. So when we tried this in question answer model as well as in summarization model, we haven't seen such kind of a response. Now this is much more comprehensive. Okay, and if you try to build a RAG model, probably you can use this as a summarization so that whoever reads it gets the total context of it. Okay, yeah, that's it. Thank you. I'm going to probably put this code in a GitLab, and I'm going to put the link for it if it helps you in any way. Yeah, thank you so much for being there.